Hello again. We're looking at example 1 in your pre-calculus part 2 textbook. This is found on page 888 in that particular textbook, and we're talking about hyperbolas this time. Now, you need to read the previous pages to understand some of the details behind this to be able to do example 1, one of which is to find the foci of a hyperbola. The one we studied for ellipse was c squared equals a squared minus b squared. The equation we have to use when we're finding the foci of a hyperbola is c squared equals a squared plus b squared. So that's going to make a real big difference there. Now, a couple of other reminders. A represented in an equation of a hyperbola, when you're talking about the general form, which is this part right here, A always represents the distance from the center to the vertex. Okay, B represents the distance from the center to what we call the co-vertex, and of course C is the distance from the center to the foci, or the focus. Now, the focus is always on the same line as the vertex. And in an ellipse, I always want to compare back, but in an ellipse, both of those, the major axis is always which letter was over the bigger number. Not the case in here. It is not like here we would say that the x-axis is the main axis, but that's not the way that hyperbolas work. The way that hyperbolas work is you look at whichever one is first, because there's a subtraction sign in the standard form of a hyperbola where there's a plus in an ellipse. So we don't look for the biggest, we look for the first term. So if x squared is given first, that means that your major axis is going to be x, or the horizontal direction. And if the y squared is given first, then we know that it's going to be a vertical one or an up and down one. And so in this equation, or example number 1, it's giving me x squared over 16 minus y squared over 9 equals 1. Okay. So again, if we have the equation of the form x squared over a squared minus y squared over b squared equals 1, and we look at the one that we've been given, that means that a squared is 16, and if a squared is 16, then a is really just 4. And if b squared is 9, that means that b is simply just 3. Okay? So, again, because that is over the x, I'm going to go left and right from my center 4. Now, because nothing is attached to the x and nothing's attached to the y, that means that my center is at 0, 0. So I'm going to go 4 to the right, and I'm going to make a vertex point. And I'm going to go 4 to the left, and I'm going to make a vertex point, which happens to make the vertex at negative 4, 0 and at positive 4, 0. The y value means that I'm going to go up 3 and I'm going to go down 3. Okay. Now, all this really helps me do is ultimately, if I go up 3 and down 3, I can make a big box here, and then through the corners of that box, let me show you what I'm talking about. You can go up to 3. You can make a big box here. Oops, went down to 4. You can make a big box there. And then if you'll connect the corners of your box, you have what's called asymptotes. Those are kind of your bumpers so that it guides your parabola. Your parabola will never go beyond those asymptotes. So it helps kind of extend your parabola. Okay, so that's one little helpful hint. Another one is, if you're trying to find your, let me erase this, if you're trying to find your C value, or where your foci is, then you're going to have to use, again, the equation c squared equals a squared plus b squared. Okay, we know that a squared was 16 and that b squared was 9. If I add those together, of course, I'm going to get 25. So if c squared is 25, of course, that means that c is 5. Again, from my center, that means I'm going to go to the right 5 and to the left 5 because the foci are always on the major axis. Now, when I have that, that means that my foci is located at 5, 0 and at negative 5, 0, which is what they're trying to state right here. All right? Now, in the second equation, we have the y squared first in general form, which means that it's going to be an up and down parabola because the y was given first. Now, that means the number under that happened to be 9. That means we're going to go up 3 from the center and we're going to go down 3. How did I know to start at the 0 point? Because there's nothing attached to the y, there's nothing attached to the x. So that means the center is at 0, 0. Okay? Now, that means that this is a squared and this is b squared this time. So if a squared is 9, of course a is going to be 3. And if b squared is 16, that means that b is going to be 4. And so again, you would put if your center is at 0, 0, you're going to go up 3 and you're going to go down 3, and that's your two vertex points or vertices of your hyperbola. Remember, hyperbolas always come in pairs. It's kind of like you split an ellipse or hyperbola and made it go both directions, or parabola, I should say, and made it go both directions. As we're working through that, we know that the vertex is at, again, 0, 3 and at 0, negative 3. If you're going to use the a squared plus b squared equals c squared, then what you're going to end up with is, c squared is equal to a squared plus b squared. And we know that a squared is 9 and that b squared is 16. Again, that leaves me with c squared equals 25. So c is going to be 5. This time, however, because we know that the major axis is y, I'm going to go up 5 and I'm going to go down 5. So that means that our focus ends up being at 0, 5 and at 0, negative 5. All right. And the hyperbolas always bend in the direction of the focus. They never bend toward the center. They always bend away toward the focus. That's why you can see that surrounded. Now, if you want to use the ideal I shared with you, if I went over 4 in both directions, I could make a big box here by going over 4, and then of course I went up and down 3. Once you make that big box and you connect the corners, what you're creating is the asymptotes, and that's kind of like a bumper guard or a guide to shape the size of what your hyperbola is going to look like. All right? Hope this was helpful to you.